equation off the home screen and put it in the equation editor and graph. So there's your equation, equation of the line with the scatter plot. Okay, does everybody get there? Everybody get there okay? So again, you have to start off with, I always forget that. You have to start off with your cursor in front of the y equals to get the equation there. Okay, now if you hit trace, you can, you're on the scatter plot. And it'll go through, if you hit your back and forth arrows, and it'll tell you what each data value is at that point. You with me? So you can go through and outline all of the data values in your output. You guys with me? So now if I go down to this particular value, okay, that value on my calculator is this the right data? I think this is the right data. I thought it was the right data.
Yeah.
I think it is.
It's difficult.
Oh, yeah. There's actually two values here right smack up against each other. Okay, there it is. It's and it's here on the screen. Okay, so when your x value is 149, your y value is 85. So this is the data coming from that one bear. You with me? Okay. So to find your residual, you take the observed y. Your observed y is the observed y value from that data point. You with me? And you subtract the estimated y, so this is the estimated value on the line at that same x. Okay, so to find that, so to find that, now hit an up or down arrow, and you're on the line. So if you hit trace once, you're on the scatter plot. Hit an up or down arrow, and it switches you over to the line. And you can scoot up and down the line. You can see your little cursor moving. Yeah? You guys with me? Okay. And now if I want to know what the value of y is, what the estimated bear weight is for one specific bear, once my cursor is on the actual line, you just type in the value of x and hit enter. So that x value was what? 149?
Yeah.
So it takes you to, so now you can see, here is the observed value of y, here is the predicted value of y. Predicted because it comes off the line, which is our predictor.
How did you bring up
Right? You with me? Sorry?
How do you bring up that x so I can look up?
You just type it in. You just type it in, 149, enter.
But how do you get to where you type it in?
Okay, you're on the, are you with your cursor on the line?
Yeah.
You can tell if you're on the line because you can see the equation up here. You guys with me?
Yeah.
Okay, so you're scooting back and forth along the line, and you just type in the numbers. Just hit the numbers, 149,
Oh.
on your keyboard and hit enter. You with me? You guys with me? Okay, so the residual, what the residual is telling us there, so you take the observed value that comes from the data, whoops. You take the observed value that comes from the data, whoops, that's down here, and you subtract the predicted value. So this is how much error we have in predicting a bear's weight that is 149 centimeters long. You with me? Kind of, sort of, starting to sink a little bit? this is heavy stuff. So you take that, again, you take that observed y, and then when you typed in the 149 and hit enter, did you get about 109.96?
Yeah.
Okay? That's the predicted y. Subtract, and your residual, notice, is negative because your data value is underneath the line. When your data value is above the line, your residual will be positive. Okay? Now, here is the actual y value. Here is the estimated y value. So is this an overestimation or an underestimation? Overestimation, good. It's an overestimation because this y value, what we're predicting, is bigger than the actual y value. So it's kind of counterintuitive, but when the residual is negative, it indicates an overestimation. When it's positive, it means that the line is underneath the original data point, and that's an underestimation. Because you're not thinking of the x value, you're thinking of the y values. Does that make sense? Okay. Yes, guys?
Does residual have its own symbol? Does it just have...
So is there a notation for residuals? Not really. Not really, they're just residuals. But we are going to want, and so the line, okay, the formulas that calculate the slope and y-intercept minimize the sum of all of these vertical distances. So that's those formulas' purpose. They make the sum, and actually you square all of these distances first to make them all positive, and then sum them up. And the excuse me, the formula's job is to make that distance as small as possible. Then we know we have the best line. You with me? So the best line minimizes the sum of the squared residuals. Okay? Automatically. You don't have to worry about it. The formulas do it for us. Yay! You're going, I don't know. And remember, you can go back over this. This is going to be posted on my website. It'll be on the online part. And you can go back over this.
Hard to comprehend.
It's a lot. It's a lot. It's a lot. And that's why I wanted, I purposefully asked to have this week videotape. It's a lot of information in 2 class periods. A way lot. Okay, so some problems will ask you to find this sum of the squared residuals. We can do that. The calculator can do that for us. So it actually wants the number that is the sum of those squared vertical distances. Okay? Okay, so once you have run the regression, then you go second stat. And in that first menu, you're going to scroll all the way down to the bottom. Now, depending on the type of calculator you have, there might not be very much in that menu at all. But you're going to go down and get that resid. If you do enter, it'll pull it to your home screen. So that little resid command is holding your residuals. Then hit the square button, which is on your first column. It's down here. That will go right there. And hit enter. So there are your squared residuals. You can call them up, then square them if you want. Whatever. So we gotta square them, then we gotta add them up. Okay? So if we go, again, second stat, and take two right-hand arrows, and you can see there's a sum function there. So if you go down and grab that sum function, drag it to your home screen, and then we want to sum the residuals that we just pulled up and squared, yeah? So now you go second, negative sign, it's going to sum the answer. You can also pull up the sum function first, then go get your residuals, just put the square inside, it'll do it all in one shot. Does that make sense?
Do we need to add the parentheses or the castle?
I don't think you have to, I just kind of do because I'm crazy that way.
You
And
go
there is the sum of the squared residuals,
And then you scroll over to that.
Got that.
okay? So again, you can go get the sum function first, then look at the residuals, put it inside the argument of the sum function, put the square on it, close the paren, and you'll do it all in one shot. Okay? But that number, that's the smallest vertical distance between each point and a line humanly possible. Okay? You guys with me? Okay? And that's how we know we've got the best line. And we're out of time for today. More fun on Thursday. Woohoo! Wednesday, sorry. Back here on Wednesday.